Today we're going to be talking about the point-slope formula again. To start off, we're going to look at some equations that are in point-slope form and change them to slope-intercept form. A lot of times it's easier to graph things in slope-intercept form because a lot of authors of problems, that's what they're giving you, and we're used to seeing it. So this is a problem we would have to start off with. Y plus 3 equals 3/4 parenthesis x minus 12. So we want to get it in this form. Y equals something times x plus or minus something. So as you can see, we want the y by itself. Over here it's plus 3. And there should be no parentheses here. So the first thing we want to get rid of is the parentheses. We want to distribute the 3/4 to the x. Everything else stays the same. 3/4 times x is 3/4 x. 3/4 times a negative 12 will be a negative 9. Again, you can either plug this in your calculator to do, or you can work out the fractions on the side. Now let's compare what we have now to this. We do have something, we have 3/4 x minus 9 on this side, but we still have the y plus 3 over here. We need to get it down to like this. So we're going to add a negative 3. These cancel out. We're left with y. We're left with 3/4 x. And a negative 9 minus 3 is a negative 12. So our equation would be changed to y equals 3/4 x plus a negative 12. Second problem. Again, we want to distribute. Start by distributing. Negative 3x minus 3. Now we're going to add our opposite over here. Plus 2 and plus 2. And we end up with an equation of y equals negative 3x minus 1. So now we went from having a point and a slope to our slope and a y-intercept. Again, our y-intercepts are usually a starting point. A lot of times we want to be looking at that. Okay. Now, we're going to start looking at creating equations from various pieces of information. When we're talking about equations of lines, we can think about 4 things. Do we have a slope? Are we given the y-intercept? Are we given a point or 2 points? And possibly if we're given 2 slopes or what we call rates of change. This particular one, this has to do with the standard form. We will not be looking at this right now, but we will in the next section. So what we looked at so far, we've been given slope and y-intercept, and we were able to do y equals mx plus b. We started looking at the slope, at the point-slope form. We're putting it in a point-slope formula. So this is how it kind of works. We're going to be working with this point-slope. So in our first example that we're looking at, write the equation of a line that passes through the point 5, negative 2, and has a slope of 3. Now I don't want to use slope-intercept form. I mean I can, but it makes it a little bit more complicated. I want to use the point-slope formula. So here's a point-slope formula. Again, y minus y1 equals m parentheses, sorry there's not an equal sign there, x minus x1. Now, we plug our information in. We have y minus, x minus. I plug the 5 in for the x. I plug the negative 2 in for the y. And the 3 in for the m. Just substituting numbers. Now I see y minus the negative 2. Change it. And I now have an equation in point-slope formula. Now if we wanted to switch this, if we want to change it to slope-intercept form, and some teachers, some professors might want you to do that. Again, we're distributing. the 3 to make it 3x minus 15. Negative 2 to both sides. And we have y equals 3x minus 17 or plus negative 17. Problem number 2. Again, some stuff I don't have to erase. I'm using the same formula. Now it's negative 8 comma 1 that it's going through, and it's a slope of 1/4. So again, the negative 8 is my x value, x1 value. My 1 is the y value. The 1/4 is a slope. X minus a negative 8, that is a positive number now. So distribute y minus 1 equals 1/4 x plus 2. 1/4 of 8 is 2. Add your opposite. Oh, I'm sorry, we could have left it like that. We could have left it right here as y minus 1. Kind of jumped the gun there. Equals 1/4 parentheses x plus 8. That's in point slope formula. If we change it to y equals mx plus b, here we go, the last step, adding 1. So you have 1/4 x plus 3. Both equations are the same. It's just in different clothing. Now you saw our numbers ended up being pretty nice here. So in this case, it would be beneficial to write it in slope-intercept form. Now this one, you're going to see that it's not that friendly if we try to do that. Okay, here's number 3. It's passing through the point 5 comma 4, and our slope is 2/3. Start by plugging our numbers in. Y minus 4 equals 2/3 x minus 5. That's our point slope formula. Right. Now if we try to change this to slope intercept, watch what happens. When we distribute, we end up with the 2/3 x, that's the easy part, but 2/3 times negative 5, nothing really cancels out there. This ends up being minus 10 over 3 or 3 1/3. Graph it, and then if we add 4 here, now we have to worry about adding mixed numbers and things like that. Now we can do that. This would end up changing to 12/3. So negative 10/3 plus 12/3. We could change this into y equals 2/3 x plus 2/3. We could write it like that, but that makes it really hard to graph. So in this case, this would be the best equation because it just avoids our numbers being fractions. So again, that's sometimes why it's beneficial to keep it in point slope formula. Alright, so moving on. Now what happens if we are given 2 points? We don't have a formula to use 2 points. But what can we do if we're given 2 points? Right. So like our first problem here. We want to write an equation with something passing through 2 comma 4 and 3 negative 1. Now what do we have here? Do we have slope right now? Nope. Do we have the y-intercept? Nope. Do we have points? Yes. Now thinking back, what out of these things, out of the slope, the y-intercept, what can we get from these 2 points? We can find the slope. So we're going to use the slope formula. y2 minus y1 over x2 minus x1. Our y2 value is negative 1 minus 4, and we have 3 minus 2. and it ends up being -5. This is our slope. Now we're right back to where we were with those last 3 problems we did. We have a slope. We can use any one of these points. It doesn't matter. So I'm going to use the first one because they're all positive numbers. Y minus my y value there, 4. I put my slope in, and now I have x minus 2. There it is. If we want to change it to slope-intercept form, distribute the -5. So you have -5x plus 10, and add 4 at the end. So you end up with y equals -5x plus 14. Okay. We're going to do one more problem here. So now we want to do problem number 2. And again, we're given 2 different points. So we have to find the slope first. So the points are -4, 5. And it's going through -2, 6. y2 minus y1, x2 minus x1. y2 value is 6, minus 5, for -2 minus a -4. Remember the minus negatives, this turns into plus. So we end up with 1/2 as our slope. Now I have the slope and a point. Again, I'm going to use the point slope formula. So again, our y1 value, I'm going to pick the first point. My y1 value is 5. My slope we found to be 1/2. My x1 value is minus a -4. Again, we have to switch this up. We have to clean it up to make it x plus 4 there. We can go ahead and distribute to kind of change it up into slope-intercept form, but I'm going to stop there. Hopefully this helps using the point-slope formula when we're given a point and a slope or 2 points. It'll work every time. See you next time.